All right, here we go. Doing section 2.2, multiplying polynomials. Before I talk about multiplying, I want to just hit very briefly adding and subtracting once again. If I've got like a blue 3x squared plus 5x minus 7, okay? And I'm adding that to 4x squared plus 3x minus 2. Okay, write this down. If I'm adding these two polynomials, addition is very easy. Okay? We combine our like terms. Like terms are x squared and x squared. I'm adding them, so there's no, I don't have to distribute anything. I just say 3x squared plus 4x squared. Some of you will enjoy stacking and putting the like terms one on top of the other. That may help you. Okay? No matter what, you should end up with 7x squared in your answer. That plus that is 7x squared. That takes care of those two. The 3x I could write right here. 3x, positive 3x, that's going to give me 8x. Takes care of that. Negative 7 plus negative 2 is going to give me negative 9. I combine my like terms. Just for review, what is the degree of this polynomial? 2. The degree is 2. What is the leading coefficient of this polynomial? Is it a monomial, binomial, trinomial, or polynomial? Trinomial. It is a trinomial. It is also a polynomial. More specifically, though, it is a trinomial. All right, let's stay with this same problem, and let's change it to minus. What do we have to remember to do when we subtract? Distribute. Write that down, circle it, and star it. If you don't remember to distribute when you're doing addition and subtraction, more specifically subtraction, you're guaranteed to get the problem wrong. You must distribute. What does that mean, distribute? That means that that negative has to go there, there, and there, all three places. You don't just put it on the 4x squared. You don't just put it on the 4x squared and the 3x. It has to go to all three places. So I've got 3x squared minus 4x squared, right? That takes care of that. What is that going to give me in my answer? Negative x squared. Our like basis, our base stays the same. If I'm doing x squared minus an x squared, the base stays the same. Okay? So that takes care of that. How about 5x minus 3x? I'm going to put minus 3x. I'm stacking my like terms one on top of the other. That's going to give me what? 2x. Positive 2x. Takes care of that. Negative 7 minus negative 2, what's that going to give me? Well, that's plus 2. Negative minus 2, what's that going to give me? Negative 5. So it's quite a bit different than what we got first. What's the degree here again? 2. What's the leading coefficient? Negative 1. Still a trinomial. Okay, still a trinomial. I just wanted to talk about that one more time before we move on to multiplying. Any questions? Anybody have any questions before I move on? Adding or subtracting? All right. First thing we're going to do with multiplication is we're going to do a monomial. Okay, an example would be 5x squared. It's a monomial. And then we're going to multiply it times a polynomial. Okay, just a random polynomial. 3x squared minus 4x plus 11. A monomial, one term, times a polynomial. This term here, this could have 3 or 4 or 5 terms, it doesn't matter. Okay, the process is still the same. The first step, or the way that you're going to do this, is you're going to use the distributive property. Okay? If I'm going to take this and I'm going to distribute it all three places, what's actually happening is 5x squared times 3x squared. I'm going to write it out. I don't ever write out the step except for the first time that we do it. Then this would be minus 5x squared times 4x. I put the minus there. That times that. It went there, and I got to do it one more time onto the 11th. Plus 5x squared times 11. So it went there, it went there, it went there. I used distributive property, and I distributed, being very careful with my negatives and my positives. Okay? 5 times 3 is 15. What is x squared times x squared? That's right. I have 2 x's here and 2 x's here. That gives me x to the 4th. The way that you say it is when you're multiplying like bases, you might want to write this down. When you are multiplying like bases, you add the exponents. And the way that I like to show it is that right there. When you are multiplying like bases, you add the exponents. What would x squared times y squared be? Would that be xy to the 4?
X squared times y.
It would be x squared y squared. I can't combine those because those aren't like bases. The only way I get to add them is if they're like bases. Got it? Questions? Anybody not sure how I got x to the 4? Raise your hand now. All right, let's keep going right here. So that took care of that. Negative, I got 5x squared times 4x. Do the numbers first. What is 5 times 4? 20. What is x squared times x? X to the 3rd, or you can shorten it and say x cubed. All right, we're almost finished. What is 5x squared times 11? 55x squared. Very good. We're going down, 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 down. We wrote it in descending order. What is the degree of this? 4. What's the leading coefficient? 15. We multiplied a monomial times a polynomial. What was our outcome? A trinomial. Okay, will it always be a trinomial? Could have been a poly, right? If this had 4 terms, we probably would have ended up with 4 terms. Okay? Very hard to say always in that type of thing. Questions? Any questions? That's all right, that's a very good question because people mix that up. You cannot add 5x squared and 11. They don't combine because they're not like terms. But you might want to write this down. You can multiply anything. Anything that you want to multiply, you can multiply together. These aren't like terms, and we multiply them. These aren't like terms, and we multiply them. It's very common to get mixed up, which is exactly what he asked for. That's a great question. Do not think that you can't multiply anything. Okay? All right, I'm ready to erase this and move on. Anybody have any questions? All right, let me erase this and we'll do another example. What method did we use to solve that problem? The distributive. Right? We're not to full yet. We're going to get there, but we're not there yet. All right, let's do another. Negative 3x times x to the 4 minus 2x cubed plus x squared minus 6. How many different times are you going to have to distribute in this problem? 4 times. What are we multiplying here? What is it? Something times something. What are we multiplying? A monomial times a what? Polynomial. If you had to guess, how many terms would your answer have? 4. Probably 4 terms. Okay? So we're going to do it here, 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 and here. I'm not going to write it out like I did last time. That takes too long. You ought to be able to do it in your head. Negative 3x times x to the 4th. What's that going to be? Negative 3x to the what? To the 5th power. All right, do it again. Negative 3x times negative 2x to the 3rd. Do the numbers first. What's negative 3 times negative 2?
6.
Plus 6. X times x cubed is x to the 4. Negative 3x times positive x squared is going to be what? Negative 3x cubed. Very good. Negative 3x times negative 6. What's that going to be? Positive 18x. Positive 18x. Is that right? All right. There's no x on the 6, right? That's why I did that. X to the 5th, x to the 4th, x cubed, x by itself. Don't think it's just going to automatically be x squared. This times this, I'll write it right here. Negative 3x times 6. There's only one x. 18's only got to have one x. It is in descending order. What's the degree here? 5. What's the leading coefficient?
Negative 3.
Negative 3. Is it a monomial, binomial, trinomial, polynomial? Polynomial is the only thing that you can call. How are we doing on time?